Electric fields near sharp points. Alright, corona's not going away just yet, but in this video we're going to talk about corona discharge and electric fields at sharp points. When we have a conductor in the shape of a pear as seen in the diagram, one end of the pear is considered to have a sharper point than the other, and electric charges congregate around these sharp points. So there's more electrons around that area and the electric field is stronger at the sharp point. So the reason this happens, first we'll look at a situation where we've got a flat plate. So we have two electrons and they want to repel perfectly away from each other, and along a flat plate the full force is experienced and they can do this. Now when we're looking at a sharper surface, say in this right diagram here, the force between these two charges is not along the plate anymore. There's a significant portion of the force that's in the opposite directions. The charges won't leave the plate, however the force is in those directions. Now the sharper the point, the more force that you're going to see in this perpendicular direction, and any charges out here will push these charges towards the point more. If you have a charged conductor that's got a lot of charge in it, at the sharp point it can be significant, and it's significant enough that the charge can be considered leaking from it. This is called a corona discharge. So what actually happens is that molecules in the air, as well as dust particles, they come into contact with the sharp point, and the sharp point transfers some of its charge to that particle. That particle has the same charge as the material. Because they're in contact, that distance between them is very small, so the new repulsion force between them is very large, and the particle leaves immediately and quickly away from that material. Now if this occurs quick enough, a spark can occur, and lightning is an example of this, as well as a Tesla coil. And if this occurs slowly enough, a glow appears around the material. Another example where this is used as an application is photocopiers. So I do have a video, I'll put another link in if you want more information about how photocopiers work. Draw a pear-shaped charged conductor and the associated electric field around it, making sure to take note of the spacing of the electric field lines.